friends, I hope you are doing well. In today's tutorial, I am going to teach you how to find the division of current among the parallel resistors. Here, to make you understand, I selected a circuit consisting of 2 resistors in parallel and 3 resistors in parallel. Before proceeding, let us have a look how current gets divided in the circuits consisting resistors in parallel. First of all, consider 2 resistors in parallel connected across a voltage supply V as shown in the figure. Let V be the voltage of source. Voltage of source. Voltage of source means the voltage of given cell or given battery. So V is the voltage, and from the battery the current coming out is V. So I equals to current coming out of the source, the total current coming out of the battery, and this current will flow from A to B. So the current I is flowing from A to B. When the current come to the junction, this is called junction, B is the junction. When the current comes to the junction, it divides into the 2 parts. Some current will flow through the resistor R1, and the remaining amount of the current will flow through the resistor R2. Let I1 equals to current flowing through the resistor R1 and I2 equals to current flowing through the R2. I repeat once again, when the current AB is coming out of the cell or battery or voltage source, as soon as this current comes to the junction, it gets divided. When the current gets divided into the 2 parts or more than 2 parts, then the circuits become parallel circuits. So R1 and R2 are parallel because the amount of the current flowing through the R1 and R2 are not same. But the voltage across R1, is V, and the voltage across R2 is also V. In case of parallel resistors, the voltage across every resistor equals to the voltage of the supply. That means voltage across R1 equals to V and voltage across R2 is V. But the current flowing through the R1 is I1 and current flowing through the R2 equals to I2. When the current I2 flows through the R2 and comes to the junction C, at the junction C, the current I1 and I2 meet once again, they combine, and from C to D the current again I1 plus I2. So I1 plus I2 nothing but the total current. I1 plus I2 nothing but total current that is coming out of the source. Now our job is to find expression for I1 and expression for I2. First of all, let us find out effective resistance. Here R1 and R2 are parallel. let Rp equals to equivalent resistance of R1 parallel to R2. Rp is given by R1 R2 upon R1 plus R2. This is the equivalent resistance of R1 and R2. Now, to find out the voltage across R1, nothing but V, and we can apply here Ohm's law. What is Ohm's law? Ohm's law nothing but current directly proportional to voltage, or voltage upon current equals to constant. Therefore, voltage equals to resistance into current. This is nothing but Ohm's law, where R is the resistance of a given circuit. Now we are going to apply this formula to get voltage across each resistor. Therefore, voltage across R1 is nothing but resistance into current, or current into resistance, one and the same. So V equals to I1 R1. Similarly, the voltage across resistor R2 is nothing but again the multiplication of current and resistance. The current flowing through R2 is I2 and value of the resistance is R2. Therefore, voltage across R2 is nothing but V equals to I2 R2. Or we can say like this also, the voltage appearing across R1 is nothing but I1 R1, and voltage appearing across R2 is nothing but I2 R2. So in the different way we can speak the same thing. And the supply voltage, from the supply the current is coming I, and the equivalent resistance we are already having Rp. Rp is equal to R1 R2 upon R1 plus R2, and the supply voltage can also be obtained by the idea, that is I into Rp. I into Rp will give the value of the supply voltage, because current coming out of the supply voltage is I, and the equivalent resistance of all the resistance connected equals to Rp. Therefore, V equals to IRP. Now let us write down this all once again here. So we are having Rp equals to R1 R2 upon R1 plus R2. Let us call equation 1. And the second one, V equals to IRP. Let us call it equation 2. And we are having V equals to I1 R1 equals to I2 R2. Let us call it as a third expression. Now I have drawn the diagram once again. Earlier diagram became messy, so I drawn diagram once again here. Now I am already having Rp equals to R1 R2 upon R1 plus R2, and my aim is to find out current I1 equals to how much. We are already having V equals to I into Rp. I is nothing but current of the source, and we are having expression V equals to I into Rp, and the voltage across R1 is nothing but V equals to R1 into I1. Now using this expression here, V equals to I into Rp, V equals to I1 R1 implies I1 R1 equals to I into Rp. I1 R1 equals to I. What is Rp value? R1 R2 upon R1 plus R2. Therefore, I1 equals to I upon R1 multiplied by R1 R2 upon R1 plus R2. R1 gone away. We get I1 equals to I into R2 upon R1 plus R2. This is required expression for current flowing through the resistor R1. Now we have to find expression for I2. For that, again the voltage across R2 nothing but V equals to I2 R2. So V equals to I2 R2, and from here we are having V equals to I into Rp. The LHS of both the equations are same, therefore comparing RHS, I2 R2 equals to I into Rp. Therefore I2 equals to I upon R2. What is the Rp value? Rp value nothing but R1 R2 upon R1 plus R2. R2 cut down, we get I2 equals to I R1 upon R1 plus R2. So this is the expression for current flowing through the resistor R2. This way the current I flowing through the resistor divides into two parts. The first part is the I1 and the second part is the I2. So let us summarize the things. The current I, here is the current through the resistor R1 is equal to I1, and current through the resistor R2 is equal to I2. So the current I flowing through the circuit, when it comes to the point B, it gets divided into two parts. They are the I1 and the second one is the I2. Expression for current I1 is nothing but I into R2 upon R1 plus R2, and expression for I2 equals to I into R1 upon R1 plus R2. By using this expression, we can easily find out the amount of current flowing through the resistor R1 R2. In this way, we can find out division of current in parallel circuits. Now let us take the example of the three resistors connected in parallel. When the current is flowing through the three resistors, it gets divided into three parts. Here I have shown the three currents with three different colors. So the current I, that is shown by the three colors, and a part of the current is flowing through the R1, that is I1. Next part of the current is flowing through the R2, that is I2, and the rest of the current is flowing through the R3. So as soon as the current comes to the junction B, I1 current flows through the R1 and I2 plus I3 flows further. When I2 plus I3 flows to the junction C, it gets divided into two parts. I2 flows through the R2 and the remaining current flows through the R3. When these currents I2 and I3 meet again at D, then the current coming out of the junction D is nothing but I2 plus I3. I2 plus I3 will come back to the junction E. Now out of the junction, the three currents meet again, I1 plus I2 plus I3. In this way, the current flows through the circuit. Our aim is to find out I1 equals to how much, I2 equals to how much, and I3 equals to how much. For that, step number 1, find out equivalent resistance, that is Rp. All the three resistors are in parallel. Therefore, the effective resistance of these three parallel resistor R1, R2, R3 given by R1, R2, R3 upon R1, R2 plus R2, R3 plus R3, R1. Here the voltage across R1 is nothing but I1 R1, that is equals to V, and the voltage across R2 nothing but V equals to I2 R2, and the voltage across R3 nothing but V equals to I3 into R3. Since the supply voltage is V, so V can be given as a I into RP. Now, as we have done in the case of two resistors in parallel, now we adopt the same idea for the three resistors in parallel. That is, V equals to I1 R1 and V equals to I into RP. From this one, we get I1 R1 equals to I into RP. Therefore, I1 equals to I upon R1 and RP nothing but R1, R2, R3 upon R1, R2 plus R2, R3 plus R3, R1. R1 and R1 gets cancelled. Therefore, we get here I1 equals to I into R2, R3 upon R1, R2 plus R2, R3 plus R3, R1. Here we observe that to find out the current I1, the resistance R1 is absent and remaining things are present here. So similarly, we can easily obtain the expression for I2 also by the same idea, that is V equals to I2 R2 and V equals to I RP. And when we got here, so we write I2 R2 equals to I into RP. By doing as above, we easily get I2 equals to I into R2 will not be there now. R1, R3 are present in the numerator. Denominator is same, R1, R2 plus R2, R3 plus R3, R1. Now, to find out the current I3, we adopt the same idea, that is V equals to I3, R3 and V equals to I RP. That means I3, R3 equals to I into RP. By using this expression, we get I3 equals to I into R1 R2 divided by R1 R2 plus R2 R3 plus R3 R1. In this way, we can get the current. We can get the current in case of the three resistors connected in parallel. Let us summarize the things now. Now, summarize the thing. To find out I1, in the numerator what is not present? R1 not present. R1 is absent. Therefore, expression for I1 equals to I into R2 R3. Denominator is same. R1 R2, R2 R3, R3 R1. Denominator not changing, only numerator changing. Similarly, when you want to find out I2, what is not present? R2 not present. This is not present. Only R1 and R3 are present. And while finding out the I3, here R3 is absent. Only R1, R2 are present in the numerator. This way, we can easily find out the division of current in parallel circuits. Now, example, here is a two resistors are connected in parallel, and suppose I wish to find out I1, I2. So, total current I equals to 30 amperes and R1 equals to 10 ohms and R2 equals to 20 ohms. And how to find out I1? The formula for I1 is nothing but I into R2 upon R1 plus R2. Therefore, I1 equals to 30 and R2 nothing but 20, and R1 is equal to 10, and R2 is equal to 20. So I1 equals to 30 into 20 upon 30, 30 get cancelled. We get here I1 equals to 20 amperes. Now by using the formula, we can easily find out I2 as well as I2 nothing but I into R1 upon R1 plus R2. So I2 equals to, what is I nothing but 30, and R1 nothing but 10, and R1 plus R2 nothing but 10 plus 20. Therefore I2 equals to 30 into 10 upon 30, 30 get cancelled. I2 equals to 10 amperes. Thus what is the result? Result is I1 is equal to 20 amperes and I2 equals to 10 amperes. This way we can easily find out the division of current in parallel circuits. Let us take one more example for 3 resistors connected in parallel. We got here the 3 resistors. R1 equals to 10 ohms, R2 equals to 20 ohms, and R3 equals to 5 ohms. Now suppose we want to find out I1 equals to how much, I2 equals to how much, and I3 equals to how much. So step number 1, R1 R2 plus R2 R3 plus R3 R1. We'll find out this one, that is 10 into 20 plus 20 into 5 plus 5 into 10. So 200 plus 100 plus 50 equals to 350 ohms. Step 2. In the step 2, I1 is nothing but I. While finding out the I1, R2 and R3 only present, R1 not present. So what is R2? R3 present, and here is a R1, R2, R3, and R3, R1. What is the value of I? I nothing but 30, and R2 nothing but 20, and R3 nothing but 5. R1 R2 R3 plus R3 R1 we already calculated, that is 350. Now see the cutting, the 0 cut down, 5 1s are 5 7s are, so we get 30 into 2 upon 7, that is 60 upon 7. Now calculator, 60 divided by 7 equals to 8.5. Therefore equals to 8.5 amperes. Therefore we got I1 is equal to 8.5 amperes. Now to find out I2 nothing but I, what is absent? R2 is absent. So we get R1 R3 divided by R1 R2 plus R2 R3 plus R3 R1. Therefore we get I2 is equal to I, that is 30, and what is R1 nothing but 10, and R3 nothing but 5, and the total of R1 R2 R3 R1 we already calculated, that is equal to 350. So 0 gone here and here, 5 7s are, so 30 upon 7. So 30 upon 7 we get here, 30 divided by 7 equals to 4.2 amperes. Similarly, to calculate the I3 value now, to calculate the I3, I into here is a R1 R2 will present in the numerator, and R1 R2 plus R2 R3 plus R3 R1. So I3 equals to, total current is 30, R1 is nothing but 10 and R2 nothing but 20 divided by 350. This and this gone down. So we get here 5 6 are 5 7 are, that is equals to 120 upon 7. So we got 120 divided by 7 equals to 17.14 amperes. Therefore, we got here I1 equals to 8.5 amperes and I2 equals to 4.2 amperes and I3 equals to 17.14 amperes. This way, the division of current in case of parallel resistors, and we had here the 3 resistors, and we could find out I1, I2, I3 is. And one more thing here we have to observe, that here the R1 was 10 ohms. The highest value of resistance was 20 ohms. The current flowing only 4.2, and the smallest resistance was 5 ohms, and the largest current is flowing. That means as the resistance value decreases, the amount of current flowing through the circuit increases. This is the one more observation we can learn from this circuit. That's all for the day. I hope the concept regarding the division of current in case of parallel circuit might have cleared now. Even though if you have more doubts regarding, communicate with me on my email address provided in the description box. Now, before saying goodbye to you, remember to subscribe my channel, and wish you good luck. Meet you again with another video another time. Till then, bye bye. See you. Meet you once again.